photosynthetic process has been happening for billions of years, and that has allowed us to store, essentially from the decomposition of plants, oil in the middle of the earth. And we now extract that and use that at a very fast pace. And so the idea is, can we do this process ourselves and do it at the scale that we need for our current energy needs? The big challenge is that you have a number of different processes taking you, for example, from the water to the hydrogen and oxygen, and we don't know which one of those is rate limiting for the product. And so that's why we need more experimental techniques that in situ look at this reaction and either verify or show how it's different than what we thought. And so, for example, a rate limiting step for the water splitting reaction is forming the oxygen-oxygen bond of one of the products. And that is suggested to be slow, but it's suggested to be slow for certain materials and not for others. So can we see that happen? And can we verify that it's slow for these and not for these? And how do we get around that? How do we get to the top where we have a high activity at a low energy input? The big things that might happen, on one hand, that might, be a spark along this continual advancement is, for example, finding when the when the bonds of the product form. The other thing that I would say is that all this advancement is continually looking at new materials, both experimentally and theoretically, and people are discovering more active materials as we go along. And there might be one that is something that surprises people.